Let's recall that a logarithmic equation is another way of describing the relationship between values that can also be represented using what we call exponential form. An equation is an exponential form when we see a base raised to a power or an exponent. That relationship can also be expressed in logarithmic form. The base from exponential form will be written as a subscript when we convert to logarithmic form. What we're equal to from exponential form is the argument from logarithmic form. And the exponent from exponential form is what this logarithm will be equal to. In this example, we're going to convert these equations from exponential form into logarithmic form. So currently, they're all in exponential form. They each have a base that's raised to a power or an exponent. So we want to take each of these equations and convert it to logarithmic form. And so we begin by first writing down the word log as an indicator that we're in logarithmic form. The base from the exponential form is written as a subscript or below the line that log is on. We say this is the base of our logarithm. What we were equal to in exponential form is the argument of our logarithm written on the same line as the word log. And a logarithm will always have an output that is the exponent from the exponential form. So in this case, -2. Let's see this again. To convert 5 squared is equal to 25 into logarithmic form, the first thing that we have to do is write down the word log. The base from exponential form is written as a subscript on the logarithm or in the position of the base of the logarithm. What we were equal to in exponential form is the argument of the logarithm written on the same line as the word log. And a logarithm will always have an output that is the exponent from exponential form. So in this case, +2. In part C, we're going to begin by writing down the word log. The base from exponential form is the subscript on the logarithm, and what we say is log base e. What we were equal to in exponential form is the argument of the logarithm, and a logarithm always has an output that is equal to the exponent from exponential form. And what we say is log base e of 1 is equal to 0. In part D, again, we'll start by writing down the word log. The base from our exponential form is the base or subscript in logarithmic form. What we were equal to in exponential form is the argument of the logarithm. And a logarithm will always be equal to the exponent from exponential form. And what we say is log base 9 of 3 is equal to 1/2. In this example, we're going to go the other direction. We're going to convert these equations from logarithmic form to exponential form. And so we begin with log base 10 of 100 is equal to 2. In order to convert to exponential form, we'll start with the base quantity. We will raise that to this power 2, because remember, a logarithm has an output that is the exponent from exponential form. So 10 raised to the 2 power is going to be equal to this argument. We're essentially starting at the base and drawing a counterclockwise circle in order to convert to exponential form. So again, we start with the base of 10. We raise that to the 2 power, and that then is going to be equal to the argument, or 100. Notice it's much easier to tell that this is a true statement when we see it in exponential form. At the beginning, we're likely not as familiar with the logarithmic form of this relationship, but this is also a true statement. In part B, again, we begin with the base quantity, which is 25, and we draw a counterclockwise circle from there. We'll raise that to the 1/2 power, and this will then be equal to that argument, which is 5. Again, when we're in exponential form, it's easier to see that this is a true statement. 25 raised to the 1/2 power is the same thing as the square root of 25, which is 5. In part C, again, we begin with the base quantity, which in this case is 2. We draw a counterclockwise circle, remembering that this logarithm will always be equal to the exponent from exponential form. And then continuing with our counterclockwise circle, this then will be equal to the argument of 1/2. And again, when we are in exponential form, it's easier to see that this is a true statement. 2 raised to the -1 power is 1/2. And for our last example, converting to exponential form, we start with the base quantity of 3, which is then raised to the 0 power, and that will be equal to the argument, which is +1.